Hi everyone. Now we'll see about the Bayes theorem. So according to the statement, Bayes theorem statement, first all these lines are like total probability, whatever the conditions we are taking, the same thing we are taking here. But here we are defining the conditional probability. In the total probability, we are taking it as a probability of an event. P of A, we are writing the formula. In the Bayes theorem, we are writing the formula for the conditional probability. Okay, so the statement is, it states that if a sample space S has n mutually exclusive events Bn, n is equal to 1 to 3 and so on n, such that Bm intersection Bn is equal to pi, meaning that they are all are mutually exclusive events, and any event A is defined on the sample space, then the conditional probability of Bn and A can be expressed as P of Bn given A is equal to P of A given Bn into P of Bn divided by P of A given B1 into P of B1 plus P of A given B2 into P of B2 and so on, plus P of A given Bn into P of Bn. Okay, this is a statement. So previously we wrote the total probability P of A is equal to formula. Now we are writing the conditional probability P of Bn given A form. That is the difference between these two theorems. Okay, now we'll go for the proof of this. Okay. First, we'll write like that you remember the joint probability. Okay, so we are writing P of A intersection Bn formula. That is equal to, otherwise if you remember P of A given Bn, otherwise you write like this, P of conditional probability P of A given Bn is equal to P of A intersection Bn divided by P of Bn. Take this as equation 1. And P of Bn given A according to conditional probability. So according to conditional probabilities, P of A given Bn and P of Bn given A is equal to P of A intersection Bn divided by P of A. Take this as equation 2. So if we are confusing with writing the formula of conditional probability, A given Bn, so write the intersection and whatever is there in the downside, you write the probability in the downside. P of Bn given A, intersection of those two events divided by whatever in down. Okay, so P of A is there. That's why P of A. Here Bn, P of Bn. Like that it is. Okay. Now, from 1 and 2 equations, what we can write from 1? Okay, from 1. First we'll write. Now, from 1, P of cross multiply. P of A intersection Bn is equal to P of A given Bn into P of Bn. Take this as equation. And from 2, if I cross multiply, P of A intersection Bn is equal to P of Bn given A into P of A. Take this as equation 4. So comparing 3 and 4. Okay, so here A intersection Bn, A intersection, both are same. So what I can write? P of Bn given A into P of A is equal to, first I am writing this, is equal to this one. P of A given Bn, P of A given Bn into P of Bn. Okay, now I am taking P of Bn given A is equal to, why I am taking P of Bn given A is, in our statement we are having Bn given A. That's why I am remembering P of Bn given A is equal to, so here P of A is multiplied. If I take this side, it will become it as divided by. So P of B given An into P of Bn divided by P of A. Okay, take this equation 5. Now, from total probability theorem, we're having P of A is equal to P of A given Bn into P of Bn. Summation of I is equal to, sorry, n is equal to 1 to capital A. This is the formula we are having. Take this as equation 6. Okay. Now substitute 6 in 5. So in place of P of A, we are writing. So what we are having, P of Bn given A is equal to P of A given Bn, P of A given Bn into P of Bn divided by what we are having, summation of this one, P of A. Summation n is equal to 1 to n P of A given Bn into P of Bn. That is equal to P of A given Bn into P of Bn divided by, if I expand this summation, first substituting n is equal to 1, P of A given B1 into P of B1, plus if I substitute n is equal to 2, P of A given B2 into P of B2 and so on, plus P of A given Bn into P of Bn. Okay, so this is the Bayes theorem 1. Okay, so still if you are getting confusion how to remember the Bayes theorem, you need to write the conditional probability Bn given A. Okay, so you write Bn given A opposite A given Bn, whatever there here you multiply with that one divided by summation of, you write here summation of whatever is there in the upper side, you write as it is in the downside. Okay, then expand n is equal to 1, n is equal to n is equal to 3 and so on. Very simple to remember. This is called the Bayes theorem. So in the Bayes theorem, if you know one conditional probability, that is Bn, A given Bn, and the prior probability, that is P of Bn, then we can calculate the other conditional probability P of Bn given A. Here P of Bn are called the a priori probabilities. Okay, so P of Bn is called the a priori probabilities. And Bn given A are known as posterior probabilities. We are calculating. We know a prior. We know the prior P of Bn, the probability of Bn, means that probability of B1, probability of B2, probability of B3 and so on. We know a prior. Those that are the a prior probabilities. And P of Bn given A are called the posterior probabilities. P of Bn given A are called the posterior probabilities. Okay, posterior probabilities. So this is about the Bayes. Okay, thank you.